4.3, modeling with quadratic functions. We all remember quadratics are parabolas, so keep that in mind. Find an equation of the parabola passing through these points. So we have to take these x and y numbers and find a parabola. So it's pretty easy using technology. Here's what we're going to do. Go into Goldadder's math functions, math sites, and you need to find the one that says quadratic regression. You can type this in, quadratic regression, not quadratic formula, but quadratic regression. So we want to type in the x numbers here and the y numbers here as a list with commas. So go back and look. Our x numbers were -1, 1, and 2. -1, comma, 1, comma, 2. And our y numbers were -1, comma, 3, comma, 8. So you can hit calculate, but it gives you the equation right there. It looks like 1x squared plus 2x, or just x squared plus 2x. X squared plus 2x. So right here, we've got y equals x squared, and I'll write that. Y equals x squared plus 2x. That's it. That's our model. That's our equation. Sometimes they'll call it a model. Equation, model, that's a parabola. So here's basically the same idea. It's just given you in a different form, but pay attention to which are the x numbers. So our x numbers are 1, 2, and 3. And our y numbers were -2, -2, and -4. So it pretty much does it automatically there. Let's see if I can just copy and paste. Y equals that. Okay, y equals that, or if you write it, y equals -x squared plus 3x minus 4. That's our equation. Next, a parabola contains the points this. Name another point also on the parabola. Well, that's the one we just did, right? It was this one. We had 1, -2, 2, -2, 3, -4. Yeah. So that was our equation. It says name another point also on the parabola. We'll just plug something in. Okay. So I don't want to plug in any one of these x numbers. Let's just pick something else. So let's try 0. All right. So 0, comma. That's probably the easiest thing to do. So plug in 0 for your x's. If you want, you can go back and use your calculator. You're going to have -0 squared, and you might be able to do this in your head, plus 3 times 0 minus 4 gives me -4, of course. So that's 1 point also on the parabola. You could do any number of points, plug in a 5, plug in a 6, whatever you want to plug in. But you could have 5, comma something, whatever you want there. Find the maximum value. Well, think about what this looks like. It's a -x squared, so we know it looks like this. When they talk about the maximum value, they're talking about the vertex. And so if we're talking about the vertex, that's where we have to do -b over 2a. You plug that in and see what you get. So -b over 2a, here's your b number, and here's your a number. So that's going to be -3 over 2 times -1. Okay, so that's a fraction, 3 over 2. Or if you want to look at that as 1.5, that's fine, 1.5. So your vertex is going to be 1.5, comma something. And that something is going to be whatever we get, we plug in that number. So we would have -1.5 squared plus 3 times 1.5 minus 4. Negative 1.75. Negative 1.75. So it's hard to see that that's the maximum value, but that's what that would be. If that point is right there, then this would be your maximum number. Notice you've got -2 and -4. This number's bigger. So your maximum number is negative 1.75. When they're talking about the maximum value or the minimum value, they're probably talking about the vertex. Next, find a quadratic model for these data. Use 1981 as year 0. So basically, this is going to be your x numbers. These are your x numbers, and these are your y numbers. But year 0 is 1981, so that means 1991 is 10 years after the start. And 1995 would be 14 years after we started, and 1999 would be 18 years. 2001, that would be 20 years. 2006, 25 years. 2007 is 26 years. And 27 years. All right, so keep that in mind there. You're going to use those numbers for your x numbers. You don't want to use 1981. So let's plug those numbers into our regression calculator. Your x numbers were 0, 10, 14, 18, 20, 25, 26, 27. And then your y numbers, 18, 29, 32, 33, 34, 39, 41, 42. Notice it calculates automatically. It gives us this. Control C to copy. And Control V to paste. Y equals, there's our quadratic model. All they're asking for is the equation there. Now, describe a reasonable domain and range for your model. So here's what I'm going to do. I'm going to take this and I'm going to graph it at Desmos. So let's go to Desmos. And it doesn't like that capital X, I don't think. Okay, so we can't see it. There we go. Let's zoom out a little bit. All right, so there's what our parabola looks like, and I forget what it asked me. What was the question? Describe a reasonable domain and a range. So we talked about this in the last lesson. Domain, you squash it onto the x, and range, you squash it onto the y. But it's kind of weird to think about this situation because your domain is your possible x numbers. And, you know, you're not going to have like decimal numbers, especially on the cents. You can't have like 18.5 cents or 29.1 cents. So it's only going to be integer numbers. So I'm not really going to write all that down, but think about it. Your time is going to have to be between 1981 and anything after that. And your price is going to be from 18 cents to 42 cents. This is kind of a weird situation because if you look at the graph, I highly doubt the price is going to go down to 0, and it's definitely not going to go to negatives. So that's kind of what they're talking about. But part C, estimate when first class postage was 37 cents. Well, that's your Y number. Your cents is your Y number. So they're wanting to know when the cost was 37 cents. So I'm looking in between here somewhere. Probably about 2004, we're guessing. Okay, in between here, probably 2004. So estimate 2004. Use your model to predict when first class postage will be 50 cents. Okay, so again, cents is the Y number. So we want to know when it's going to be 50 cents. Well, it's going to be after the year 2008 because of the way it's going up. I think the easiest way at this point is to look at the graph, okay? So we want to know when the cost is 50 cents. Here we go. Okay, let's do this. I do y equals 50. Right there. Year 41. 41 years after the start, it looks like. Okay, or also 191 years after the start, but that's, I don't think it's going to go down. So let's just look at this one. Let's say 41 years after the start. 41 years after 1981 would be what? 2022. So 2022. A model for a cannonball is shot into the air, and there's the equation where t is time and h is height. Find the maximum height. Okay, well, the maximum height, they're talking about the vertex again. So this is B, and this is A. We're doing negative B over 2A. All right, so that's negative 32 on the bottom. Let's use a calculator for that. Negative 140 divided by negative 32. $4.375. Now remember what you just found, or what we just found was the x part of the vertex. How do we find the y part? Well, we need to plug that number in. Plug that number in right here for t. So we have negative 16 times 4.375 squared plus 140 times 4.375 plus 4. 310.256. That's a little bit weird how I wrote it, but 310.256 feet. That's the maximum height of the cannonball. Find the total time the cannonball is in the air. Well, let's Desmos this thing again. So we've got negative 16x squared. Notice I used x, not t, plus 140x plus 4. Okay, that's a weird looking parabola. It's really steep, isn't it? Here's what I'm going to do. Let's change the x-axis to go from negative 5 to 30. Okay, that looks a little bit better. And I want to find the total time the cannonball is in the air. Well, really all I need to do is find this. Okay, this is the time. The x-axis, we're talking about the time. So 8.778 seconds. That's how long it's in the air. It starts here at 0, shot, and it lands right here at 0, means that's the ground. 8.778 seconds. Last thing, there's a question that talks about time, and it gets a little confusing because sometimes your numbers don't really mean your numbers. You almost have to go to military time. 4 a.m. equals 4, and 10 a.m. equals 10. And of course, noon is 12 o'clock, so we call that 12. But here's where it gets confusing. We're not going to use 3, all right? 3 a.m. would be 3, but 3 p.m., think about military time, it's 3 hours after noon. We're going to call 3 p.m. 15. And 8 p.m., that's 8 hours after noon. So 8 p.m. is going to be 20. Again, think about military time. That's what we're gonna need.